Yes, we can.
Okay, all right, no problem. I was trying to. All right, so good morning, everybody. Once again, as this young has introduced, my name is Dimitri. So, and today we'll be talking about industrial introduction to industrial control systems, sensors, actuators, and controllers. So, what I have thought about in trying to present, what we'll be learning this morning is that I've tried to just make it a high level introduction, so that regardless of whatever level you are, you'll be able to learn something. I don't plan to make it too long, but it's just to give you some tools that you probably need to look at. I have a textbook that I would say really helped me, and I recommend to people all the time. Lessons in Industrial Instrumentation. So it's a book, it's a resource that I would recommend that you may want to read to give you more insight on some of the things that we'll talk about today. At the end, hopefully, I plan to do a small demo, but I think because I'm at home, I can't connect my PLC and also join this meeting at the same time. So I think I'm trying to see how to work around that challenge. All right. Um, all right. So just for the newbies here, what is industrial automation? Automation is the design, programming, and configuration of systems to enable them function with minimal human intervention. So the way I always like to explain this is if you how many people think about a Coca-Cola plant, and I don't believe that somebody is going to go there and be using their hands to pour Coke inside the bottles and put the caps and everything. So we have to design the system such that when you push a button, the system is able to automatically give you Coke in a carton or in a what do you call this thing? Yeah, in a crate at the end of the day. So all the guy, everything that goes into designing that process, controlling it, and visualizing it is the entire scope of automation. Automation is also changing because we are having IoT and a bunch of other things which I would not really want to go into today. So there are two major branches. There is what we call domestic automation or home automation. That's, people have smart homes where you enter your house, you clap your hands and the lights come on. You can, is somebody writing on my, okay. You clap your hands and the lights come on. You can speak and then maybe the speaker in your house will come on. That is a little more in the vein of domestic automation. Then there's industrial automation where you are talking about process plants, like the example I gave, Coca-Cola, oil and gas manufacturing, almost any large scale production facility falls under industrial automation. So there's something else I'll call building automation. I don't know whether to classify that as industrial or domestic, but depending on the scale of the facility, building automation is almost in a space of its own where it has special controllers. You can use standard controllers, but it has some special devices built for it. All right. So the next thing I'll be talking about is the automation pyramid. So typically, this is the old paradigm. Some things are changing now, but when you are trying to define, what exactly are the different levels that you can come into automation at. So this is the general scale. We have the field level, which contains the sensors and actuators, like we mentioned. Then we have on the second level, we have the control level. That's where you have like your controllers and your DCS systems. Then on the third level, we have the supervisory level, which is for SCADA. Like at this level, some people may know different like Wonder, where we see a professional factory talk for those with some experience in the field. But just before I go above this level, one of the things I always like to emphasize when I'm talking to people about automation is that people have different strengths and you can come in at any level. There are some people who don't like programming, for example. There's not a little bit, there's a lot of programming involved in automation. So there are people who say they feel more at home with hardware. So in many cases, those people work as instrumentation engineers or instrumentation technicians. So those are the guys that will go into the field. Let's say I have a transmitter, I have a sensor, I have a device that I want to install in the field. You send them to the field to install. Of course, you need a little bit of knowledge of some of the other areas, but you can decide that you can make a very, very comfortable living staying at this level. If you are working in oil and gas, people get paid millions of naira just to be experts at working. Some people will tell you, okay, they can work on specific valves, they can work on this. They are just experts on those particular things. Then on the second level, when it comes to the PLC programming, there are some people who just love programming. I'll give the analogy of front end and back end engineers. So PLCs are like the back end of automation. That is where you actually write all the very complex code that runs the infrastructure. So there are some people who are more at home just with programming, right? And then at the top level, we have the supervisory level, which is more of the visualization. How do you actually visualize the process? Because in many cases, it's not as if you are going to be actually monitoring the code when you are trying to run a process. It is from the visuals that you're going to control it. So those three levels is what they are what you typically find on most production facilities in Nigeria. In many cases, they stop at the SCADA level. Then, but for more advanced facilities, you have the plan level, which is the MES and the historian. The MES is the machine execution system. The machine execution system is where you have things like work orders. So this can state something like, okay, we want to produce a bunch of cartons, or want to produce, like if it's like that, the Coke factory I mentioned, we want to produce Coke, Fanta, and maybe one other drink. You are going to send that order down from the MES, and that's now going to be planned and distributed across the machines. So one of the most interesting areas to work in is integration between the supervisory level and MES. So there are people who are I don't know if there are people who are a little more interested in IT related skills and all that. At this level, you are able, with some level of supervisory knowledge, you are able to integrate these two systems. You need to know about databases, like for a historian, this is for storing your data. You need to know a little bit about IT for you to be able to work at this level. So generally, I recommend this level for people who are a little more IT inclined. Then yeah, same thing for this level. Enterprise resource planning basically sits at the top. That is where it talks about your payments, your billing, where you are dealing with your customers. This gives you a top view of your system. Now, like I mentioned here too, integration of all these levels is probably one of the most highly paid skills that you can get and you'll find in the industry, because a lot of like this is well paid, working at this level is well paid, working at this level is very well paid. But as you go up the pyramid, because if you really think about it, when you are working on the enterprise ERP level, you are probably managing information for multiple facilities in a company. And if they have somebody who is able to integrate at different levels, then that person becomes a very valuable asset. And there are unicorns who know everything from the bottom of the pyramid to the top of the pyramid. You can be that guy. There's nothing stopping you. But in my experience, I've found that people tend to skew in one direction. So, Miss Yoma, if there are questions, you feel free to just let me know. So I'll try to get to them. I want to make it as interactive as possible. Does anybody have any question yet? Or I
All
should
right.
go on?
Okay, so I'll be letting you know as the questions come up, and then I'll unmute. Or better still, if anyone has a question, you can put your hands up, then I
Then
unmute
if
you
you just drop it
specifically.
in the chat, then
All
yeah.
right.
All right. Okay. So the next thing that I just want to simply talk about is signal flow in a control system. So a typical, let me go forward. Yeah, okay. Let me do this here, and then I'll go back to that slide. So in a typical control system, you have a process that you are trying to monitor. For example, let's think about something that boils water for you. Or let me give you an example. Imagine that you are boiling water in your kitchen and you place the pot on fire and you turn on your gas. That is an example of a simple process. In the industrial setting, that could be a steam boiler where you are trying to generate steam to heat other parts of your process. So the first thing is the first part of a control system is the process, which is the physical system that you are trying to control. Now, for you to do any form of meaningful control, it means that you need to actually monitor what is happening in the process. So the first thing that you need to do is to monitor your process. For things like this, imagine I'm going to be giving different analogs. Oh, somebody raised their hand. Yeah, what's the issue?
All right, so there's a question from Mr. Joseph. He says, which of the levels in the previous slide is the best for a beginner to achieve and maintain?
All right, so what I would say is that start at the bottom, and then we started from the bottom, and now we are here. So it depends. So I would say that it's helpful to learn to start at the beginning to understand how sensors work and how I think the first two levels are probably where you spend your maybe the first part of your career or maybe like the first 1 or 2 years and then you move like with a little bit of the SCADA level. So I feel I would say that focus for the first few years of your career, focus on these three because they work hand in hand. Then this can be saved for later. And in many, many cases, people never even get to this part of their career. So I would say that for the first part of your career, just try to focus on this. They work hand in hand because you connect a sensor to a PLC or like any sort of controller, and you want to do some sort of visualization. So just focus on these three levels. All right. So let me just quickly go then. So in this particular, I was talking about the process, right? So that's the physical system. I gave the example, which I'll show in the next slide. I gave the example of a steam boiler. Like you are trying to generate steam for a process. So for that, and I was talking about, putting a pot on fire, right? If you put the pot on fire, one way is for you to know that it's boiling is for you to just keep going back to watch it, right? And if you're a crazy person, you can put your hand inside the pot to feel the temperature. But what you are really trying to do is to sense what you are really trying to do is to sense the process. So for you to sense something in the process, you need a measurement device. So just one minute. So So you need to have a measurement device. And that measurement device is taking readings from the fields and is sending them to your controller. So this is where you have transmitters and a bunch of things that I'm going to cover later. So then the information goes to your controller. So think about your controller. You could imagine a human being in this process that I gave the example of you trying to boil water, right? You can look at the water and say, okay, this water is too hot or it's too cold. If you feel that it is boiling, then you can decide to turn it off. Or if you feel like, let's say you're cooking jollof rice, if it gets close to, like you start out maybe with very high amount of heat, when you are getting close to your rice being done, you may decide to reduce the amount of heat. So that is what a human being would have done in that kind of process. But in this case, since we are automating it, we are using a controller, and the controller decides what to send to the field. Now, the controller sends a signal. The device that finally executes the controller's command is the final control device. So let me give you an example. I'm going to ask a question and I want people to maybe somebody decide who will answer. So if you are walking to has anybody walked towards all these automated doors in hotels? If you are walking towards the door and the door automatically opens, how do you think that happens?
Okay, can raise your hands. I'll pick based on first few to raise their hands. Okay, Engineer Collins. Okay, you can unmute.
Good morning, all. Thank you so much. Okay, so from my own knowledge, I feel that there's a sensor.
I can't really hear you. I don't know if it's very clear.
So the sensor will just first of all. Okay. Can you hear me? Hello. Can you hear me?
Yes, we can. Now we can. Yes.
Okay, beautiful. Okay, now the first one is the sensor. The sensor, I don't know the name of the sensor, I don't know the type of sensor, but all I know is that there is a sensor that senses an object. If an object may be of a particular distance or a particular weight, I don't know how it works, senses a human being coming, then it will send signal to a PLC or something like a controller. The controller will now tell the actuator to go and trigger this kind of a motor, so that motor will roll on and then roll out the door. I don't know. From my little knowledge, that's how I explained it. I don't know if I'm correct.
Yeah, that's perfect. That's perfect. So I just wanted us to get a sense that you are walking towards a door. So there is the process is, let's call it that door system, right? The door, the set of doors and everything involved in it. But as you are walking towards the door, a sensor detects that there's a human being coming. So that sensor is our measurement device, right? So in some cases, some people call it a proximity sensor. The proximity sensor, there are different types of proximity sensor, photo eye and all those kind of things. The proximity sensor detects that somebody is walking towards the door, and then it sends that signal to the controller, and the controller then decides that, okay, if you are sense something, then it's sending a command to the motor to open the door, right? And then that door now opens for the person. So in this case, your motor is your actuator. Do you understand? All right. So I'm trying to.
Sorry, so there's someone that made a recommendation of a motion sensor. I don't know if you can shed more light on the difference
Yeah, so
between them.
motion and proximity just means a motion sensor can function like a proximity sensor. Basically, what it just does is to detect if there's somebody coming towards the door. Any sort of sensor, there are different technologies that you can use to achieve that. But the point is that there's some sort of sensor that detects that somebody is walking towards the door. That's the most important thing. They are not getting into the specifics of the technology that is being used. Do you understand? Mm-hmm. All right. So the
Thank
next thing I
you.
just want to talk
Sorry, there's a
about is the
question.
signal
Sorry.
flow. Okay.
Sorry. So a question from Salome. She says, from what I have observed at my workplace, working with SAP appears to involve sitting for most of the day, raising notifications and work orders, and working extensively with Excel sheets. This seems quite boring, quite repetitive, and frankly boring. Could this perception be biased? I would appreciate a brief but in-depth overview of SAP and ERP system from a management perspective, as well as the pros and cons of working at this level, aside from the monetary benefits.
All right. So you know what is going to happen? That is a brief but very detailed question. So what I would do is that I would maybe let's defer some of the questions to the end. I feel like maybe I'll just finish and then I'll answer all those questions. One thing I would say is that or I'll pause periodically just to check if there are questions. So one thing I would say is that yeah, if you work exclusively with ERP, maybe it's boring. The thing is, what is boring is relative to different people. Some people like clicking documents and doing Excel. I don't know. But for me, I am looking at it more from ERP systems can be used to do different things. It's not just for automation. We are looking at it from an automation point of view. And I'm not looking at it as you just being a user of the ERP. Do you understand? I am looking at it as like on this period, I'm talking about you being the engineer that is going to design the integration of data that is coming from your SCADA to your MES and how it is going to flow into your ERP. Where I work, like we have systems that we built to integrate, data from one place into ERP, use API, data, blah, 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 and all those kind of things. We don't use the ERP at all. In fact, I've never seen the ERP, but we integrate data into it. Do you understand? So they will give us an endpoint and then we'll find a way to send our data there. So look at it from the point of view of being the engineer that works on the integration of data to ensure that if there is a transmitter or a valve that goes bad here, the data is able to flow all the way to the PLC, to the SCADA, to the MES, and to the ERP. So look at it as the engineer building the system, not as just an end user who is just clicking buttons. So what I'll be doing is that I'll be periodically pausing for questions, and then you can just feed me the questions. Do you understand? All right.
Yeah.
So so the next thing I want to talk about, I already here I mentioned, the components of a control system. I believe we now understand that the input, I mean, there's input and there's output, which is what I'm actually going back to explain now. But we've talked about the sensor, which senses signals from the field, and then there's a measurement device that takes that information and then sends it back to your controller. The controller looks at it, makes a decision, and sends it to your final control device, which is your actuator. That's actually impacting process. All right. So now let's talk about inputs and outputs. Pardon the crude drawing by the right. I just tried to make it up this with the tool. All right. So when people talk about inputs and outputs, especially with respect to automation, there's usually a little bit of confusion. The standard way of defining automation is that what I call the field here, some people, you can just call it the process, right? So input signals are signals that flow from the field to the controller. Output signals are signals that flow from the controller to the field. This is a very simple definition, but when I ask people, for example, if I give you this device, is it an input or an output? Then people start mixing things up just because they are not defining it from the point of view of the controller. So the controller is our reference point. You don't treat the device in isolation. So inputs are signals that go from the field to the controller, and outputs are signals that go from the controller to the field. All right. So I've already covered this. All right. Now, I'm going to show you, this is a typical example of a control system. Don't be intimidated by some of the things that you are seeing. It's not a very complex system. We'll go through it one by one. And we'll look at, okay, what are the inputs to the controller? What are the outputs? Where is my sensor? And where is my actuator? Okay. Okay, somebody's writing on the screen. I didn't know how that's possible. Anyway, so we have this system. I gave you the example of, boiling water in your kitchen. Just think of this as an industrial kitchen where you are trying to generate steam to be used in a boiler or different parts of your process. So what this system does is that there's water that is coming in from anywhere. It can be from like any source in the facility, and that water is going into this pipe. And what we are basically trying, and then you have a burner that is constantly heating the water. So what we are basically trying to do here is to ensure that we have enough steam that goes into that process. Now, there are two considerations. There's a device here, it's called a level transmitter. What it does is that it just monitors the amount of water inside the tank, and it reports it to the PLC. If there's too much water, then there's a problem because water droplets will enter the pipe and it's going to cause problems downstream on the line. And if there's too little water, then that means that you are not going to generate enough steam, or you might even be running the system dry, which is going to cause all sorts of problems. So here we have our transmitter, which reads signals and sends them to our controller. Then based on the program that we have written to say, okay, I want my level to be at this point, or this is the minimum or maximum level I want to set for my controller. The controller then now sends a signal to this valve. So this valve is what opens it. So the valve may open a little more or close a little more to ensure that we have enough water in the system, right? Now, I'm going to ask a question. Anybody can answer. So where is my sensor? So the first question is, what is my sensor? What is my actuator? And what is my input? And what is my output of this process? So maybe one person can answer. So one person can answer.
Ologwa Caleb. Sorry, I don't know if I pronounced it well. Raise his hand first. So, you can unmute yourself, Caleb.
Good morning. Well, the question again, the input and the output, right?
Yeah, the input and the output, or what's the sensor, what's the actuator? Yeah.
Okay, the sensor is the level transmitter. It senses the level of water. Then the actuator is the air-operated controller. That's a pneumatic control system. That's the actuator that that controls then the control device is the LIC. the level indicating controller. Then the input that comes to the control device is the level of water that the level transmitter reads. That's the input. Then the output, it is the control to the actuator. Tell it how much to open. If it's to open to a certain amount or to close.
All right, no problem. So that's very good. Now, I want to just to build upon your answer. What if you really listen to what he just explained now? He differentiated between the sensor or the sensing device and the signal. Do you understand? So here now, we mentioned that we have an input, we have a sensor, we have an actuator, and we have an output. So in this case, I don't know how do I write on this thing? Yeah. Okay, so this is it. Okay, I don't know. So this is the signal, right? Then this as well is the signal, right? So this is the signal, right? So in this, sorry, let me go back. Yeah. Yes. All right. So, let me to clean this. All right. So in this section, the signal, the input signal that is coming to our PLC or our controller is the level, right? But the sensor or the sensing device that is reading that level is our level transmitter. So if you say, what's the input? The input is its level of water in the tank. But the device, the sensing device or the transmitter is the level transmitter. Then in this case, our output is the degree of opening of the valve, but the final control element to our actuator is the air-operated control valve. Now, don't worry too much about the signals for now. We'll talk about that a bit later. All right. So now, going a bit deeper into it. Now, when everything we are talking about is in relation to control systems, right? So the first thing, like there are 4 types of signals, which I'm going to just elaborate a little bit upon now. So we have already talked about the input signal, which is a signal that goes from the field to the PLC, and then an output signal, which is a signal that goes from the PLC to the field. Now, here you can see that there are 4 major classifications. I mentioned digital input and analog, digital input and output, analog input and output. So the first distinction that we first need to talk about is, I don't have a slide for that, but hopefully if you are listening, you follow what I'm saying. So a digital signal is a signal that is either on or off. It is either true or false. It is defined based on its states. For example, here I have a picture of a push button. A push button is either pushed or not. A proximity sensor is either sensing something or is not sensing something. A motion sensor is either sensing or is not sensing. Same thing with this lamp that is on the right. The lamp is either on or off. A motor is either, or a pump is either running or not running. Though there's a little bit of debate around that. You can have something like a relay or a contactor, which I'll give examples, either on or off. So when you're talking about digital signals, there are signals that are defined based on their states. So the more accurate name is binary, because digital can mean, like binary, octal, hexadecimal, blah, 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 for computer science people. But for our own purpose here, when we say a digital signal, typically they mean a signal that has only on and off states. So now, then analog signals are signals that vary, that are not defined based on their states, but based on their value. So an analog signal does not have a simple on or off. It does not make sense to define it that it is continuously varying. So you can have temperature, for example, it doesn't make sense to say that my temperature is on or off. It doesn't make sense to say that my pressure is on or off. It makes sense to say my pressure is 5 bar, my temperature is 22 degrees. So you define them based on their value and they are continuously varying. So if you put the input signals, input and output signals together with the digital and analog, we now have 4 broad classifications of signals that you experience in the field and of signal types. So the first one mentioned digital inputs, digital outputs, analog inputs, and analog outputs. So let me just go a little bit over that. So digital inputs, I've already given examples. You have sensors, you have push buttons, you have three-way switches, and all sorts of other devices. They are on-off signals that read a signal from the field and then transmit it to the PLC. It does not make sense to say, oh, I've pushed my button halfway. It's either you pushed it or you've not pushed it. And generally, the voltage level that you find with a lot of inputs that go to the PLC is 24 volts. You can have to 20 volts, but the most common signal that you'll find on the field is 24 volts. So same for digital outputs, the example I gave, you have a pilot light, it's either on or off. You have a motor starter, it's either it's energized or it's not energized. You have a solenoid valve, it's either open or closed. Same, you have analog inputs. I mentioned potentiometer, pressure transducer. Here, this is a temperature transmitter like RTD. All these are things that are used to measure signals. But the kind of signals they measure they are continuously varying. And these signals go from the field to the PLC. So analog outputs. So we have a proportional valve. Now, on this valve, a proportional valve is a valve that opens in percentages. But there are also on-off valves. There are valves that you can send, like I plan to do a short demo at the end. I still don't know how I'm going to go about presenting that because I don't, well, we'll see how to go about that. But on-off valves are valves that basically only open or close. Like you have some ball valves and other devices. But then you have some proportional valves that can open 0%, they can open 40%, they can open 30%, they can open 50%. You have linear actuators that can move maybe from one position to another. Then you have a VFD speed where you are trying to vary the speed of the VFD. VFDs are generally used to vary the speed of motors or pumps, where you don't want the motor or pump to run at a constant speed and you're just trying to vary it, in many cases from 0 to 50 hertz. Now, before I go ahead, just to focus on this VFD now. If somebody asks you, what is a VFD? Is a VFD an analog output or analog input? Who is going to give me an answer? There's a reason I'm asking that question before I explain.
Okay, Usman, you can unmute.
I can't hear
Hello,
you.
good morning.
All right, good morning.
Yeah, a VFD
Yes.
is an analog output device.
Okay. All right, that's good. Does anybody have any other answer? Because I know I put it on analog output, but there's a reason I'm asking the question.
Okay, let me put the next hand that was raised. That's Emmanuel Salami.
Yeah. Good morning. Can you hear me?
Yes.
Yes, we can.
I would say based on what we were taught now, I would say it's an analog input because it is going to send out signals to control the speed of our AC or induction motor.
Yes. Okay. So let me have a look, right? So let me just not to waste time. Let me give you the answer that I think. People feel free to correct me. But first from this, if we are just to give a very simple answer, I told you that just to the person that says an analog input, I said that your point of reference must always be what? Your controller. So your controller is the one that is sending the speed command to the PLC, to the VFD. So that would be an output because your controller is the one that is trying to vary the speed of the VFD. But there are devices that may not just function as one signal. You know, I mentioned that when somebody was answering, it distinguished between the device and the signal. There are some devices that have multiple signals on them. So they have, for example, let's look at a proportional valve now. You know that a proportional valve has a command that it receives from the PLC, that is an analog output. But the many proportional valves also have something called a feedback on them, where they will tell you what the valve has actually opened to. The reason you need to know this is that there are times that there may be a problem with the valve. A valve may have an issue. Maybe there's a blockage on the line. So you have told the valve to open.
Yeah.
What? So you have told the valve to open up to 80%. Somebody needs to mute their mic. You've told the valve to open up to 80%, but the valve is stuck. Maybe there's a blockage on the line, and the valve is only open to 20%. The PLC has to have a way of knowing that. So in that case, the PLC uses the feedback. So a more accurate explanation or a more accurate representation would be to say that the feedback of the proportional valve is an analog input, while the valve command to open to a certain percentage is an analog output. So if a proportional valve can have both the analog inputs and the analog output components. Same thing for the VFD as well. There are devices that have composites. They are composite devices, I call them. So if you go to an interview and they say that the VFD, a digital input, or is it analog, or is it this? The best answer is to say that it's a combination of everything. So let me say, so this one, I need to edit. This is analog output actually. So a VFD has two major commands. You vary the speed. You can vary the speed, but it also needs to get a command that will tell it to actually run the signal. Do you understand? So a VFD, the run command to tell the VFD to turn on, to run the motor, or to not run the motor is a digital output because it is on off, right? And it is coming from the PLC. But when you run when you tell the VFD to run, you need to also confirm that it is running. Do you understand? You need to also confirm that it is running. So that in that case, that is a digital input, the feedback back to the PLC. So the run command is a digital output. The run status is again. Yeah. The run status is a digital input. In some cases, so just give me a minute. Just give me a minute. All right. So the run status is a digital input. So same thing for the speed command. This is a typo. I sure it should be analog output. So you are telling the VFD to run at a certain speed, 0 to 50 hertz, which is not just on or off. After it has run, then you are now telling it to run at a certain speed that you can change. It can be 25, it can be 35, it can be 35.5. That is an analog output. I will correct that. And then the feedback of the valve, of the VFD, to say, okay, I told you to run at 50 hertz. What is it actually running at? To confirm that. It's like sending somebody a message, and then the person has to confirm that they have actually delivered the message that you sent them. Or it's like I told you to give the person 1,000 naira, and you went and you gave them 500 naira. I need to be able to know that the amounts that I gave them, that I sent to give them, is what the person will also say that you gave them. So just think about it in those terms. So you have your speed command and then your speed feedback. So if somebody asks you what kind of device is a VFD, it is a composite device. There are different signals on your VFD. So it does not make sense to really classify. Though if you are forced to pick one, many people just say the analog is an analog output, which is what I mentioned here, but it's the VFD speed command. And like I mentioned here as well, for the proportional valve, in many cases, you tell it to open to a certain percentage. You also have another signal that gives you feedback as well. So I'll pause here if anybody has any question before I go ahead. I'll take one or two questions. If there's no question, we'll move on.
Yeah, at the moment we do not have questions, but I'll let you know. I don't know. Does anyone have a question? Maybe
No.
just drop it in the chat. Okay, so
All
we
right.
have someone's hand up for question.
Okay.
Okay, let me unmute him then.
Yeah, hello, good morning once again.
Yeah, good morning.
Yeah, I would like to ask a question. It's regarding powering an induction motor without any VFD, just a direct start and stop.
Yes.
Is there a way I can integrate a feedback that tells me, okay, when this motor is on, I want a situation where when I'm not on the field, based on the feedback I'm having on the SCADA, I can definitely and accurately tell that yes, this motor is on. Is there a way I can program or wire a feedback of a contactor to tell me that on the field this motor is actually on and I'm not getting a false signal?
So what I can say is that it all depends. The only thing you can know is that your contactor has latched, right? And if that contactor latches, you can use the auxiliary. There's an auxiliary contact on your contactor that you can now feed back to your PLC. So that is, if you are not going to use like VFDs or anything like that, if the contactor latches, the auxiliary contact, some of them have normally open, some of them have normally closed contact. Well, I've not explained that, but the auxiliary contact can be wired back to the PLC. So that I think that's the simplest way to just achieve what you mentioned. All right, so let me just quickly go on so that not to take too much time. So now I'm just going to be going through like different examples of PLCs and some other things so that we will just get a sense of what we'll be meeting in the future. So typically there are like many major brands. I just picked three. If your favorite one is not here, please don't be angry. I know I should have. So Siemens is one of the largest manufacturers of PLCs in the world. Very popular in manufacturing and the power sector. Rockwell Automation. So Siemens is more popular. It's a German company. So if you are planning to emigrate to Europe, I very strongly recommend that you work with Siemens PLCs as a starting point. Rockwell PLCs, or some people call them Allen Bradley PLCs, are manufactured by Rockwell Automation. It's a US company, so it is majorly found. It's found in a lot of places, but you will find it a lot more in oil and gas. So if you are planning to go to the US or Canada, in some cases Australia, and you are planning to build a career in oil and gas, I very strongly suggest that you work with Rockwell PLCs, Allen Bradley PLCs. Yeah, Rockwell Automation is the company. Allen Bradley PLCs are the hardware devices. Then you have ABB. ABB is also a very popular brand. It's more popular in India and Middle East and Asia, like Asia and the Middle East. I would say that is where you find a lot, and Africa as well. You find a lot of ABB. They are very strong when it comes to power. I'm not sure you find them a lot in oil and gas. They are very popular when it comes to power and motion control, when it comes to robotics and a bunch of other things. Yeah. Obviously, then there's Schneider. which is not on this slide, but Schneider is like a worldwide brand used everywhere, used in water treatment, used in like the entirety. I don't know if I'm authorized things, I don't know, but the entire, from what I know, the entirety of like major LNG facilities in Nigeria are run almost exclusively on Schneider. The refineries that we have, like they are mostly run on Schneider, and then the Aveva platform. So, but yeah, all right. So I think I already mentioned this, that the components of a typical PLC system. So I just took this screenshot from the TI portal. This is for Siemens. There are similar ones for Rockwell and other things, but I just picked this because it's a little more visual. So when you are trying to set up a simple automation system, you have just the standard components that you need. You have your power supply, which is what is going to power your entire rack. Like this is what's going to send 24 volts to allow all these devices to come on. We have our CPU. Now here I'm using an image of an S7-1500. So just think about that. You're looking at it from the point of view of a computer, right? You have your power supply, you have your central processing unit, and then you have your peripherals, which are your inputs and outputs. So it's basically the same thing because a PLC is just an industrial computer. So here we have our power supply. In some cases, you can just use an external power supply. You don't have to use one from Siemens. You have your CPU, which is the brain of your computer. This is majorly where you are going to all your programs. When people say they are writing programs, they are uploading, they are downloading, they are doing all sorts of things. This is the major device that they are interfacing with. And you can see some communication ports here. This is how you communicate with your PLC. I will show you another image later in a few minutes that actually shows that there are other ports, but this here is Ethernet port. So you connect an Ethernet cable and actually use that to program your PLC. This is where you'll be loading your program. So then these are IO devices. I mentioned we have digital input signals, digital out, analog input, analog output signals. All those signals is the same way. For example, if you are trying to detect touch, right? You use a mouse. You have this. You are trying to play sound. You need a speaker. For example, you may be playing music, but imagine if your speaker is bad, you won't hear any sound. So the PLC needs cards that it uses to receive signals from the field and to send signals back to the field. So we have digital input, digital output, analog input, and analog output. These are the typical signals that you would find, or typical components that you find. There are communication modules, motion control modules, weight checking modules. I don't want to go into that because to make it a bit too complex. Now, one thing I want you to all notice is that you can pick apart the different components of this system, which they are clearly visible to you. So this would be the example of what we will call a modular PLC. So just think of it as your desktop in the office. You have a monitor, you have your CPU, you have your mouse, you have your keyboard. All of them are separate. So if your monitor goes bad, you don't need to change the entire system, right? But if your keyboard goes bad, just get a new keyboard. So it is expandable, but in many, many cases, getting the full setup is a bit more expensive, right? So modular PLCs like this are generally used in facilities where you need to constantly keep expanding, or where there are constant changes, or for large systems where you are not sure of the number of IOs that you are going to need at the end. The counterpoint to that is, since I gave the example of compact PLCs or modular PLCs, the counterpoint to that would be I gave an example of modular, so the counterpoint would be compact PLCs, which would be similar to having a laptop. In many, many cases, if your laptop goes bad, you cannot just, you can change the screen, but you will need a special engineer to remove the screen and put it for you. Your keyboard, your CPU, you cannot really tell all those things apart just from visual inspection. All of them are embedded in the same frame, which means that it's easy for you to carry your laptop everywhere and do your work. But if something goes wrong on your keyboard, you cannot just quickly you can get an external keyboard and other things. But if you want to use the original keyboard of the system, it has to go and get fixed. So think of compact PLCs as the same. There are PLCs where, in this case, now see the way we can see our CPU and our IO separately. In this case, everything is fused together. So if something goes bad, then in many, many cases, you have to change the entire device. Now, what I would say is that there are some PLCs that function somewhere in between. For example, these are Siemens 1200 PLC. Some of them, it's a compact PLC. It means it has the CPU, power supply, IOs, and everything embedded on it. But there are some of them that are expandable, which I will try to show later. There are some of them that are expandable. So they play in this medium range where you can have it as a compact PLC, where you know exactly what you need for your requirements. You can say, okay, I need 10 digital inputs, 4 digital outputs, 2 analog inputs, and then I'm good to go. This is the PLC that will suit my needs. So you typically find it with OEM supplied machines. So if an OEM supplies you maybe a small mixing machine or a small cutting machine, they know the number of IOs that are in that machine. They don't expect you to modify it. They will just put the PLC that they think is appropriate because it's cheaper, and they make it a day. They call it a day. But for the modular PLCs, think of you are running a big production facility, you are producing biscuit coke, or you are producing crude oil or anything like that. Your process is constantly changing, and you want to be able to easily swap IOs if one goes bad. So before I move on, I would just want to ask, so let's just a quick question. Who would tell me what the typical, like the advantages of using compact over modular? So let's say I tell you that I want to build a small conveyor to produce, to wrap, to create a wrapping paper for maybe, I don't know, maybe biscuit or something like that. Which PLC would you pick? Somebody should try to answer. iPhone. All right, so I think somebody needs to answer. We need to pick somebody to answer.
You take the question again.
What I said is that I want to create a small conveyor system that will produce wrapping paper for biscuits. Like, which of these PLCs do you think I'll pick?
Okay. I think iPhone was the first, so iPhone.
Hello.
Okay, so it's, can you hear me? Good morning once again.
Yes, we can. Please proceed.
Okay, so I would say it depends on the feasibility in terms of expansion in the nearest future. If the project is just for that purpose in the next 10-15 years, I would use a compact. But if there are chances of expansion in the nearest future, I might need to use a modular PLC.
Okay, so that's a very good answer. That's a very good answer. It means you're listening. All right. So if you are thinking about expand, let's say it's not just that labeling match. Maybe you now want to incorporate other things to be making your own modifications later. Then you most likely go modular. Then costs as well. Sometimes if you have a lot of money to spend, you can just decide to go for modular upfront, regardless of just so that you have that flexibility. All right. So now, as just to focus a little bit on the different OEMs and the available software. So for the Siemens side, there are different levels. So this one here, I didn't label them, but here you have, this one is the 200. This is very old, but you still find it in Nigeria. It is still in use. So this is the 200. You find it mostly in Chinese, in machines that are supplied from China. So it's majorly discontinued now, but this programming software is MicroWin. You find it, if you know, you know. So then for S7, this is the S7300 and this is the S7400. The S7300 is probably the most widely available PLC in Nigeria, but it's set to be discontinued by 2030. but it uses a software called Semantic Manager, but you can also program it with the newer version TIA Portal. Then you have the S7400. This is mostly used in like cement facilities, environments that require redundancy or very, very harsh environments. It can also be programmed with either Semantic Manager or TIA Portal, which is the newer software. Then you have the 1200, which if you will see, was built as a direct replacement to the S7200. It's programmed exclusively using TIA Portal. You have the 1500, though the image here is the ET200SP. I did not mention that. ET200SP and this 1500 can be programmed using TIA Portal exclusively. So I think this slide is in the wrong place. So for Rockwell Automation, we have our MicroLogics, right? Series, which is programmed using RS-Logics 500. We have SLC 500. This is very old. It's programmed using RS-Logics 500 as well. Now we have Compact Logics, which is the mid-range PLC for Rockwell. Now, just to make a point here, okay, do you know what? Same thing for Control Logics is the high end. All these ones are programmed using, there are two softwares, two pieces of software. So if you are for anything from version 20 and below, the name of the software is called RS-Logics 5000. While for anything for version 21 and above, it is Studio 5000. So if you hear people say, no, RS-Logics 5000, Studio 5000, it is basically a firmware distinction. So if you are programming anything for version 20, it is RS-Logics 5000. Anything from version 21 and above, it is Studio 5000. Control Logics is the most capable Rockwell PLCs, and this is what you typically find in an oil and gas application. It is used where you need redundancy and like motion control and very high performance requirements. Compact Logics is, let's call it the mid-range of the control of the Rockwell ecosystem. So we have ABB as well. So we have AC500, uses automation builder, which is used for very small automation systems. Then we have the EC800M, which is used, depending on whether you're using it as a PLC or a DCS controller, uses something called the Compact Control Builder or the 800XA Control Builder Professional. So I didn't mention Schneider again. Apologies for not mentioning Schneider. For Schneider, there are different ranges. There is the Schneider M221. There is the M580. Then there's the M340. M580, you have the Quantum PLC. And I think there's another one. I can't remember the other one. But you have that. Then they use a software before. They used to be called Soul Machine and Unity Pro. Soul Machine was used for the lower range, while Unity Pro was used for the higher range, the M580 and Co. But now they are called
Hello.
Yeah.
Hello. Please, for Schneider, can you write out the software that is being used for writing the PLC, programming the PLC for us, please? Thank
okay,
you.
so maybe somebody will help me type. So Soul Machine, S-O, the old name is Soul Machine, S-O-M-A, like machine, right? Then the other one, then for the M580, M340, it is called Unity Pro. That's the old name. But the new name is, I believe it is EcoStructure Machine Experts and EcoStructure Control Experts. I believe I am saying that, I hope I'm right, but I believe EcoStructure Machine Expert and EcoStructure Control Expert. So maybe someone can just type it in the chat so that people can just note that. But those are the piece of software that you use for Schneider. Yeah. Somebody will put it in the chat.
So we have some questions.
Okay.
Yeah, I've sent it to the chat already. We have some questions.
Okay.
Yeah. Okay. So first, can you use auxiliary contacts to wire indicator light for feedback? That's the first one.
Yes, you can. So you can do anything you want. The idea, it doesn't have to go back to the PLC, right? So imagine that you want to show that the motor is running. So all you simply need to do is, if you have a lamp, you connect 24 volts to one end of your auxiliary, then the other output of your auxiliary is just going to go to the positive terminal of your lamp, and then the negative will go to a ground somewhere. So the idea is that anytime, because all we are dealing with is voltage and current, you can wire it anyhow you want. Instead of that signal going back to the PLC, you can just do it such that when that contactor is energized, the output of that auxiliary is going to your lamp and it's just going to indicate that your motor is running.
All right. Thank you. Second question, is Rockwell as open source as Siemens?
Both of them are not open source. Maybe I understand your point a little in that Siemens plays well with third-party systems. Like there's a Modbus library, there's this library, there's that you can just import and use with Siemens, while Rockwell generally works within its own ecosystem of devices. So think of it as using Android and using iPhone, right? So with Android, you can install your apps the way you want and all that. Siemens is a little more open when it comes to that. But Rockwell tends to work with, it's like iPhone, they tend to work with their own network of devices and partners, like they have their own protocols. Siemens have their own protocols. In fact, you can build an entire ecosystem with Siemens devices. But if you are trying to integrate with third-party systems, I would say that Siemens is a little easier. But what I would say is that Rockwell is also changing. Because of competition in the market, they have seen that they have to open up some of their PLCs. So before, if you wanted to, this is not part of the scope, so nobody should ask me further questions what I'm about to say. But if you wanted to do Modbus on a Rockwell controller, what you would have needed to do before was to buy a ProSoft communication module. But now, for I think up to 5 devices or so, you have a Modbus block that is now available on the modern Control Logics and Compass Logics PLCs.
Okay, thank you. Next question is, does this imply that the VFD can operate and be programmed independently without using PLC communication?
Yes, it can. It can. So in fact, in many cases, we are talking about PLCs and all this. If you go to a lot of places in Nigeria, they don't even have they just want to use a push button to just to start their machine, and then when they want to stop, they want to stop. They don't care about all this. And then if they are trying to vary the speed, they will just use the potentiometer on the body of the PLC. So in some cases, some people, they don't care about automation. Like they don't care about having beautiful graphics. They don't care about all this. They just want to start. So you can just have a PLC. You can just have a VFD that can run independently. You use push buttons to control it, and then your status signals can just go back to your indicator lamp or something like that. And then for your potentiometer, you can just use your hand to just stop the signal. And then there will be a display on the VFD to know the speed that it's actually running on.
Okay. Another question is, Siemens software are readily available and license can be gotten with EKB. Is that possible with Rockwell?
So whoever is asking that question, there's no answer to it. There's an answer, but there's no answer. And I will not say more than that. All right. That's the only, I know this policy, so that's the only answer I can give you. I cannot say more than that. So, anyway, so let me move on. I will come back to your question, right?
Right, please, so just to add on, people that have questions, please just drop it on the chat, so that we'll just ask him once for his next break for questions. Thank you.
All right. So I think I already covered most of what I wanted to say. The last part is just the naming conventions for PLCs. So you have digital inputs, like just to show you what it would look like. So if you have for Allen Bradley now SLC 500, you have I:1/3, which means this is an input, is a digital input signal, is on slot 1 and is input 3. If you are using Control Logics, it is local 1, data 3. This is just the naming convention. Is local which means that it is directly on the PLC. There's remote IOs, which I'm not going to go into, but this is local, which is directly on the PLC. It is the fourth, well, if you are counting from 0, is the 4th signal. Then say when we look at Siemens I0.3 across all the entire family, there's no complexity. GE, you can see Omron, you can see Mitsubishi, you can see Code 6, which by extension is what Schneider, ABB, and a lot of other Beckhoff and a lot of other brands use, is going to have a convention like this. So CodeSys is like an open source PLC platform that people just build on. Like ABB uses CodeSys, Schneider uses CodeSys, and a lot of other platforms use CodeSys. The idea is to make sure that, if they were trying to create some sort of uniform PLC standard, because the problem that people were having was that you have spent 20 years programming Allen Bradley and you want to switch over to Rock Siemens, and then you have to start learning conventions and programming standards afresh. So CodeSys and the IEC standard, IEC timers, and all those things were just brought in to kind of standardize the entire thing. So I will not go. So you can see for digital inputs, digital outputs rather, this should be O actually. Then analog inputs, analog outputs, and then you can see all the other things here. All right, so I think I've covered most of what I want to say. So there's a demo I was planning to display a program before, but as I found out, I cannot be on this meeting and also connect my PLC at the same time. I think I'm having my Wi-Fi is going to shut down if I do that. I think I need to look into that. But just so that you see, this is the TI portal software. I don't know if you can see very clearly. Oh, sorry. I'm trying to type. So here, this is just a small, so you can see we have the CPU, the S7-1200. Then here we have our S7-1500, which is a modular PLC, like I explained, right? And here you can see that apart from the ones I showed in that image, you can also see an extra serial port. If I want to extend, I can just simply add an IO here. For the 1200, you see that I just have my PLC. Yeah, even though I have one small card I can add to it, I don't have extra expansion. So these ones here are for communication. But I also explained that depending on the kind of PLC that you have, you can easily expand, even though it is compact. So let me give you an example. So if I come here, let me change it to a different kind of PLC. I click OK. You can see that now I can then, it's lagging a little bit. I can then have more IOs if I want to add more signals. Do you understand? So before it was not expandable, but using a different kind of like a more advanced S7-1200 with more expansion slots. Then, in fact, depending, if I only need 2 expansion slots, I can even change it and say I want to go for a lower version. That one will only give me access to 2 expansion slots. So these are part of the things that would make you a good engineer. You need to know exactly what you are trying to design. So here now, if I only need limited expansion, I can buy 1-to-1 is expansion, 1-to-1-2 is limited expansion with only 2 slots. Then 1-to-1-4, you start from 8 expansion slots. Then you can go 1-to-1-5, 1-to-1-7. That gives you more IOs on the embedded PLC itself. So let me stop sharing. I want to try to see if I can share from my other my phone. I have a rig just to see if I can walk you through some things.
Okay, there are 2 questions. Just to throw it there. We have someone who raised his hand asked, you said something regarding firmware on Rockwell. He wants you to please buttress more on firmwares with regards to Rockwell automation. Well, he's trying to do that. Okay, let's just give me some minutes to set up, then we'll get back to your questions. How is doing that? Please, let's drop comments. How is the session going so far? Are you learning? Are you growing? Hope it's interesting. Please just drop reactions or drop comments on how you are feeling.
So Isioma, I was actually trying to talk. Can you help me spotlight that view?
All right.
I'm trying to see. I just to show people what I have, and I have that's the best I can try to do.
All right. You're spotlighted now.
Okay.
Okay, so you have 3 new questions. You want to take that before you go ahead?
No, don't worry. I'll answer the questions at the end.
All
I'm
right.
cognizant of time.
All right.
So I don't know if you can see the rig. So here is just a makeshift rig that I have in my house. Well, I brought it from the office. So we have this is a power supply here. This is a Siemens. Can you hear me?
Yes, we can, but there's an echo. Maybe you'd use the device you're using to record to speak.
Okay. Can you hear me now?
Yes, it's better now.
No echo, Abi.
No echo now.
Okay, so just give me a minute. Trying to increase oh, can you hear me now?
Yes, we can.
Okay. All right. So what I was trying to show is that this is a PLC. This is a Siemens PLC that I have here. I don't know if there's any design on it. Okay, so I don't think so. Well, I don't know. Somebody was just trying to test something. I don't know what is here, but this is a PLC. This is just a simple design that somebody did. Then here you have a power supply. Here the PLC is linked to an Ethernet switch. The HMI and PLC are linked. So here you can see that I have, this is just a small test thing that we use. So we use the small S7-1200 because we already know the number of IOs that are required, right? So we just size it. We have a 1200 PLC with the DIs, DOs, and then we use the limited expansion slot for the analog output. So here you can see the relays which will function as output. Here you can see I have level transmitters here, the level switches here. So basically to tell me, okay, this is for low level, this is for high level. Both of them are not active because it's below that. Then I have 2 valves here. These valves are digital outputs. They are digital valves. It means that they can either fully open or fully close. That's what you have there. Then, but I also have an analog valve here. This analog valve opens in percentages, right? Then here I have pressure transmitters. These things here are meant to read the pressure on the line. So right now the pressure is 0 because I would have loved to test the whole thing, but let's just manage what we have. So this is the pressure transmitter. Then this here is to record the flow on the line, the flow transmitter. Here we have a makeshift pump. So this is the pump. It's just a miniature pump, and it's meant to pump water in. So it is a digital output. It gets the digital output from the PLC, and then it runs at the constant speed to pump water through the system. So this is a simple control system that we have. Yeah, and you can see that we are using a 1200 because it's a system where everything is tightly defined. We know exactly what to expect. You can see now, if I touch this thing, I'm just manually energizing it. If I touch this thing, you can see the red lights, and you can see the red light here. If I remove my hand, you can see it to go off. If I touch it again, then if I touch the one at the top to force it to set, you can see. Then same thing, if I turn on the lamp, you see the IOs here. This is for the analog output. So yeah, I think there's a lot more I can say, but I just hope that within this time you've been able to at least get something out of sensors, actuators, get a sense of what they do, why we need them, and yeah. All right, so I'll stop my video, and I think I'll just answer my questions from this device.
All right. So the first question you have is to buttress more on Rockwell firmware. If you can talk more so that the person properly understands how Rockwell firmwares operates? That's the first question.
Is there still an echo now?
Sorry, speak again.
Is there an echo now?
Not really.
Okay, I just want to confirm that there's no. Okay. All right. In fact, I think I'll leave on the other device after.
All right.
I've stopped sharing. All right. Okay, so we cannot see my screen. All right. So tell me the question about the Rockwell again.
Firmware, Rockwell firmwares. Person wants to know more about Rockwell firmwares.
Okay, so Rockwell releases new versions, so they will tell you that for different reasons, maybe there are bug fixes, there may be some new features that are only available. So they will release, let's say they are on version 15, they will release version 16. They will tell you that, okay, if you want to have access to this feature, it is from version 16 and above. And you need to get the corresponding software. So if you are going to be programming with firmware version 16, you need to get RS-Logix 5000 version 16. But what now happened is that they were using RS-Logix 5000. Along the line, they now got to RS-Logix from RS-Logix version 20. Before the software, they had RS-Logix 5000, they had their factory talk, which is the HMI. So, but they now, with TI Portal, Siemens also had different software, but they now came into this era where they were trying to consolidate everything inside the same environment. So from version 20, they created something called Studio 5000, which Studio 5000 is what houses their, from version 21, Studio 5000 houses both the programming software, the factory talk. So you have Studio 5000 Logic Designer, then you have inside that you can have factory talk view, you can launch other applications from within Studio 5000. So if you are planning to program any PLC that has firmware from version 21 and above, you will use Studio 5000. Anything from version 20 and below, you use RS-Logix 5000. For the RS-Logix 500 series, for example, if you are using MicroLogix 11, the MicroLogix 1400, and you are trying to use Modbus TCP, I believe that is only available from, I think, version 11, and you need to have, I think, the MicroLogix, I think, Series B, MicroLogix 1400 Series B PLC. So there are sometimes only certain features that are available on certain firmwares for a particular PLC. Do you understand? There are in some cases, there are even some hardware changes that are made. For example, Siemens PLCs before used to have, I believe, 3 boards. If you open it, I think the ones that were from version, I think 11, version 12, or version 14 or so, those that were running on those firmware, they had 3 boards inside them. But then Siemens now changed the design to simplify it to 2 boards. So there are all those kind of changes, all those kind of differences I find in PLCs. All right.
Okay,
question.
thank you very much. Next question is, how can one obtain training kits such as a mini PLC controller, level transmitter, and actuator for hands-on learning and practice?
How can you acquire it? How do I answer that? There are different ways. So these are things that you can buy off the open market. And there are things. So I work somewhere. I don't want to, like, this is a how do I put it? It's a non-partisan thing. I don't want to start saying too much, but there are ways you can typically just get. What I generally advise, we just buy a small PLC. You can get it off the open market, eBay, and a lot of other places. Just buy a small 1200. You can get push buttons and lamps in Lagos, like Oshodi, Alapa, different places. Yeah.
Okay. Which of the S7 series is out of phase for Siemens?
300 is going to be phased out in 2030. 200 has been phased out everywhere apart from China. But you will still find it. The fact that it has been phased out does not mean you will not find it.
We can't hear you. I don't know if you're muted.
Can you hear me? Isioma?
Yeah, okay, now we can hear you.
Okay, so what was the last thing you heard? Okay, so I don't know what there's. I'll just answer the question again. Siemens 300 is going to be phased out by 2030. 1200, 1500, and 400 are still active use. N7 200 has been N7 200 has been phased out everywhere apart from China. All right.
Huh?
Okay. Okay. So next question
is how and where can we get a way to download TIA Portal and the Step 7 software license for practice?
So you can get a 21-day trial from Siemens websites. For the license, I believe it's possible to get, but I may not want to say too much on that again. But what I can say is that you can get the software license. You can get the software from Siemens website. I believe that there is a package for students, I think 1 year, if you are still in university or you still have access to your university email. I think that Siemens also has something like that for students. Just Google maybe Siemens software for students or for educational purposes. I think there are packages like that.
Okay. Someone said, I've not really had time to. Oh, okay. Answered. So thank you so much for your explanation. One statement caught my attention. Someone programming Allen Bradley for 10 years now decides to start with Siemens, leading to building Code Cs as a universal software. My question is, what is the transferability of PLC programming from one OEM to another? I assume the logic stays the same and expect the representation should be the same as well when programming in ladder logic, your SCL and your STL. So what is the transferability of PLC programming from one OEM to another?
So I'll say that it's fairly transferable. It's not too different, to be honest. If you know how to write a simple large program in Siemens, once you understand the environment, like let's say I try to write the same thing in Rockwell, it's just basically, first thing is, how do I connect to this PLC? You learn how to connect to the PLC. Maybe Siemens, you program within TIA Portal with Rockwell. You may need to use the RS links or factory talk links. You use that to connect to your PLC. Then how do I, what is the addressing? You know, there's a slide that shows, let me go back. There's a slide that shows the different addressing mechanisms. I don't know where that is. Yeah, the different addressing mechanisms. So here, if I have a simple program like, I 0.0 should turn on Q 0.0 or something like that. If I'm writing it in Rockwell, it will be maybe I:1/0, I:2 Q O:2/0. It's just the syntax that is different. Though I would say that for more advanced applications, maybe there will be more difference. Like if you're trying to implement Modbus in Siemens, you may need to watch. If you have implemented, you know how to implement in Siemens, you may need to just know how the block is going to work in Rockwell. So I would say that if you learn two platforms, it is easier to learn the third one. So I'll give you an example. I had already learned how to work with Siemens and Rockwell, and I'd learned a little bit of Mitsubishi, right? So there was a time the first time I ever really programmed on site, that was 22 years ago, Sha. It was in Abba, and it was a Delta PLC. Up until that time, I'd never programmed Delta in my life, but I learned how to program it on the bus on the way there. I watched the videos, and the moment I figured out, okay, this is the kind of programming cable you need. This is how to download to the PLC, and okay, you write a simple program X0 to turn on Y0. The timer works this way, similar to Mitsubishi. So once you know about two platforms or three, but once you know two, I would say that it is very, very easy to learn a third one. It's just like for people that play instruments, they will tell you that if you know how to play one or two instruments, they can pick a new instrument up much, much faster than somebody who has not really learned any of those.
All right. Thank you. Next question is, when you're familiar with softwares like Siemens, either S7 or TR Portal, will you be able to troubleshoot or navigate your way, most especially reading and understanding your circuits, especially if it is on other types of PLCs, ABB and co. So basically, would you be able to still read the logic? Would you be able to navigate if you were to move from Siemens to an ABB or move from Siemens to another solution?
Yeah, I think that's the question I just answered.
Basically, yeah.
Yeah, I think that's the question I just answered. If you know one environment, you can really just easily transition to other environments.
All right. Can you please discuss on communication media for signal transmission in sensors, actuators, and PLC?
No, I do not want to do that. I believe that that's going to take too much time. So maybe communication media, you're talking about like 4 to 20 milliamps, 10 volts. For signals, you may want to talk about like Profibus, some ASI. Yes, like I feel that we would probably talk a little more about those ones later. It's going to take too much time for me to go into, but for transmitters, you can have 4 to 20 milliamps, you can have 0 to 10 volts. You have Profibus, ASI, there are some transmitters that support Modbus RTU. There are many, many ways you can pull signals. There's Profibus PA, there's Foundation Field Bus. Like the communication is a completely different topic that we can spend a lot of time going into.
All right. Someone is asking, okay, so someone says he finds it easy to understand ladder logic on TIA. That is for Siemens rather than Allen Bradley. Is there a systematic explanation for this approach, that is to understand using Allen Bradley as someone that is used to Siemens?
It's just practice. Just to give you an answer, when I started, I was a Siemens enthusiast. I love Siemens. The first time they tried to teach me rock, I was like, why is this thing? Why is this so difficult to use? Why do I have so many pieces of software? Why this and that? Why this and that? And I just abandoned it. But then there was a time I had to work with it. And I spent about a day or two picking it up. And the moment I figured it out, I found that, you know what, it's not so bad. And I got to a point after working with Rockwell for a while that it started looking easier to me than Siemens until I went back to Siemens again. So I would say that you just need to stay with it. And that's it. That's the only answer I can give you. When you stay with it, you begin to understand it more. And then it begins to become easier for you. It is normal for people to just stay with things they are used to. So if you move to a different environment, why am I clicking around so much? It can be a bit confusing, like understanding the addressing and all that. But once you figure it out, you just stay with it. Yeah. There's no systematic approach. Just stay with it.
Right. And then someone is asking, said you mentioned a textbook. Please, what is the name of the textbook that you mentioned that you recommend people?
Lessons in industrial instrumentation.
Sorry, call that again. I can put it on the chat.
Lessons in industrial instrumentation.
I didn't get that. I'm sorry.
Lessons.
Lessons. Lessons in
industrial instrumentation. Yeah.
By who, please?
Just you find it. I can't remember. I think it's a roof out or something like that. R roof out, something like that. Or K roof out. Let me see if I can find his name.
Okay, someone said, yeah, Tony R. Kupald.
Tony R. Kupald, something like that. I don't know. They've typed it in the chat, yeah.
All right. Thank you. So someone is saying he wants to ask his question over speaking it out because he's not sure he'll be able to type it. Should I proceed?
That means it's long, but you can ask. Just try to be brief.
Okay, so let me give him access. That is his name. Ologwa Caleb. All right, let me give you access. Ologwa Caleb. All right. I don't need.
Good morning once again, or we're already in the afternoon. Good afternoon. Well, this is more like a conflict of interest to me. But before then, I want to appreciate you for putting our time to train us on this. And even I was at the Automation Fest, Nigeria Automation Fest. Ever since then, on that day, I was very confused, like, what am I into? But since then, I've been trying to learn some things. And yeah, it's been a wonderful journey since. And now I have this kind of this interest in oil and gas and HVAC. So even last week, I was at the VRV training on HVAC. So I noticed that they had this kind of controller system that they have a lot of expansion valves, thermostatic, electronic expansion valves, solenoid valves, and they have lots of things on their systems. But I didn't really, I don't know about the controllers and everything. And also, I still have this interest in oil and gas. What can I do? Like, what can I learn in general that I can apply to all these areas in case anyone comes? Like, I'm just a fresh graduate, so I don't know where next.
Well, first thing I say is that no knowledge is useless. Everything you learn is useful to you. Like there are so many things I have learned that they come in when I'm not even prepared at all, like or when I don't have time to prepare. But I would say that learning how to program PLCs is a skill that applies across industry. I've worked in manufacturing, I've worked in power, I've worked in oil and gas, I've worked in water, I've worked in like almost any. Pharmaceuticals is the only industry I know I've not worked in because it's very highly regulated. But I've worked in almost every environment you can imagine, and it's just the same PLC knowledge. I know how to work with transmitters, valves. I know how to work with that, but I'm not an expert. Like there are people that are experts on valves. Do you understand? And they will work in that industry and they will do very well. But if you learn how to program PLCs, I would say that you can pretty much work anywhere and do any like you walk into any room and you'll be useful to them. Yeah. So, but you will need to pick up the knowledge of other things because when you are working with PLCs, you don't work with PLCs in isolation. They are meant to control real world devices. So you still need to gain knowledge of all those other things. But I would say if you have very, very strong PLC programming skills, you are not likely to be out of a job.
Thank you very much for that. Guess I have a little bit of direction now.
Thank you.
Okay, thank you. Someone asks if a CP card of a PLC is faulty, the whole system runs down. How can this be mitigated, judging from a professional view?
So if your communication card runs, if it goes down, so the question I have to ask is, without knowing the exact setup of the system, it's difficult to say. Maybe because it's possible that that communication module is communicating with some very important devices like valves. Maybe there are some remote devices using Modbus or other things that it needs to control that are integral to the functionality of the system. But one thing I would say is that, at least with Siemens, there are, even with Rockwell as well, there are fault handling blocks like hardware interrupt blocks and a bunch of other things that can ensure that if a fault occurs, it remains isolated. Do you understand? It remains isolated. So that it does not take down your entire system. So it will just show up. You see that your system is faulting, but then your system will still continue running. You know that there's a fault, but it will not take down your entire system. So we have my TI portal just to show you what I mean by that. You can see some under this organizational block. You can see rack or station failure. You can see pull or plug of modules, their diagnostic error, time error. What all these things do is that they help you to handle these faults if they occur. So that it won't be that because somebody pulled a module or there's a station failure, like maybe one of your remote IOs just failed, then it takes down your entire system. All these blocks will ensure that the system continues running while you resolve the fault. Like I said, without knowing the specifics of the situation. Are you saying something?
No. So all right. I think for now that is
And that should be the last question. I think we are over time already.
Oh, please ask more questions. Ask more questions, please.
So
Your chance, please. All right. So
Can I ask one more?
oh, yes.
Yeah, ask.
All right. Can we have more of classes like this? Is it going to be possible? I know you are very, very committed to
So there's going to
that.
be the answer I would give is that it's a series that we are planning. This is the first of several classes that we're going to be having. More specifics would be released. Just follow the LinkedIn page, Nigeria Automation Hub on LinkedIn. Just follow the LinkedIn page. We're going to be announcing webinars like courses that you can watch on, not like webinars that will be coming in the coming months. And there are going to be videos that you'll be able to watch. We are going to put some exercises. We have a lot in store. So just watch out. That's what I'll say. Just follow the LinkedIn page for Nigeria Automation Hub.
All right. So thank you, everyone. So we have a lot of questions that are more of so I'll take these ones. So for the slides, so yes, a recording will be shared to the group. So I dropped the link to the group chat. So please join the group chat so that you can get more updates on upcoming webinars, upcoming events, and everything that we're going to be doing. So please let's all join. Then for upcoming things, so yes, we are for certificates. I know someone asked if we are issuing a certificate. So like I said, we'll communicate on the group chat, but what we have planned is going to be um something with regards to a series. So we're not doing this as one off. So rest assured that this is going to be continuous because we want more engineers in the industry. We want That's the whole point of Nigeria Automation. We want to create more awareness and more people on the field. So we are going to be doing this as a series, and the certificate comes at the end of the series. So we'll communicate with you on the different various forms of certificates that you get and how you can get them so that you can share to your friends, talk to people, and also make your plans towards getting these certificates. Then for I think so this person asking, yes, you are. Oh, hi, Raindorf from Ghana. Yeah, I'm glad to have you here. You can still participate. Would like to have more people, so please spread the word with regards to Nigeria Automation Hub. The link to the group chat, I shared it already. I'm resharing it now, so please join the group chat for updates. Then also for future events, so we are having an upcoming training bootcamp. So we are going to have a training boot camp where we train people thoroughly. Will not be easy on you. We'll train you very well to ensure that we have a high standard engineers coming out through this platform. And then there's also going to be competitions through the year. So it's not a case of maybe it's just trainings. No, we are having competitions. We are having additional webinars. So we're going to have webinars span across the year, and you're going to keep getting posts. So please stay up to date with us. Join the group chat. Follow us on all our socials. We have LinkedIn. We have Instagram. We have a lot of social media platforms. So please and please and please, let's take our time to join all these platforms and be on standby for the bootcamp, be on standby for the competition, and be on standby for how you can get the certificates for our program. I don't know if that answers all the questions that we have with regards to upcoming things. All right. So thank you so much, everyone. So lastly, we will drop another poll. Yes. So I'm going to drop another poll, and this poll is for us to try and understand, okay, how you we got a poll before the event, so we understood where everybody was. So and now we want to know how you are now, where your mindset is, um where you want how you want us to help you grow. So I'll be sharing that now. So please take out 5 minutes to take this poll. Okay, poll has been launched, so please go ahead to take the poll. Okay, General Neo. So the poll should be on your screen. If you can't see it on your screen, if you're using your phone, tap your more icon, tap poll and quizzes, and then it comes up. If you're using your laptop, also tap more and tap poll and quizzes, and then, all right, great. Don't forget to hit submit. All right, we have 50% already submitted. Please let's keep it coming so that this will help us do better, know how we can improve on the next session, and know how we can grow. So please take our time to take the poll. Thank you very much. Okay, 1 minute to go and I would end the poll. Thank you so much for participating. Highly appreciate everyone here. It's an honor to be your host or your moderator, rather. So please keep the polls coming in. We have 80% and have already taken the poll. Let's hit that 100% mark, please. Okay, and that brings us to the end of the poll. Thank you, everyone. It was an honor to have you here. It was really amazing. So thank you so much, and hope to see more of you. Bye, everyone.
Bye, everyone.
We are the thinkers, we are the builders, we automate, we elevate. Now we move Nigeria forward, through every system, every line, with skill and vision so divine. Together we rise, together we test the power of progress. Niger Automation Fest. From PLC to SCADA flow, innovation makes us grow. We like the spark, we lead the quest. Automation drive our nation's best. We automate, we innovate. We move Nigeria forward. We move Nigeria forward. We move Nigeria forward. We automate, we innovate. We move Nigeria forward. We move Nigeria forward, through every system, every line, with skill and vision so divine. Together we rise, together we test the power of progress. Niger Automation Fest. We automate, we innovate. We move Nigeria forward. We move Nigeria forward. We move Nigeria forward. We automate, we innovate. We move Nigeria forward. Nigeria forward. We move Nigeria forward. We automate, we elevate. We automate, we elevate. We move Nigeria forward, through every system, every line, with skill and vision so divine. Together we rise, together we test the power of progress. Niger Automation Fest. Nigeria forward. We move Nigeria forward. We automate, we elevate.